Hello, this is Lab 11 Transformers. Transformer is widely used in our daily life. This figure shows a transformer. The primary side is connected with the power supply, and the secondary side is connected with the load. There is no direct electrical connection between the primary side and the secondary side, but the primary side and the secondary side is magnetically coupled with each other. One thing we need to remember is that transformers only work in AC circuit. It only works in AC circuit. During the lab, some students connect the primary side with a DC voltage source. This might damage the transformer. So remember, it only works in AC circuit. So in our lab, we will use the function generator to provide a sine wave as the input on the primary side. Let's take a look at the ideal transformer model first. It is shown in figure 1. And the value N here is the turns ratio. The definition of turns ratio is the number of turns in the secondary winding over the number of turns in the primary winding. And we have the voltage relationship, that is V2 equals N times V1. Because this is the ideal transformer, we do not consider the loss. So the input power equals output power. So the output voltage V2 equals N times V1. So I2 equals I1 over N. So that's the voltage and the current relationship of ideal transformer. Figure 2 shows a typical transformer application. That is, we connect the load ZL with the secondary winding. And let's take a look at the input impedance seen as the primary side. So that is Z1. Z1 equals V1 over I1. And we know V1 equals V2 over N, and I1 equals N times I2. So we can obtain that Z1 equals ZL over N squared. So the input impedance seen at the primary side is equal to the impedance attached to the secondary side divided by the square of the turns ratio. Now let's take a look at the first order low frequency model as shown on figure 3. When compared with the ideal model, there's two resistors R1 and R2 and two inductors L1 and L2 and M. M is the mutual inductance between the primary and the secondary winding, and M can be calculated using this equation. And K is the coupling coefficient, which is between 0 and 1. In this lab, we will carry out experiments and calculations to obtain the value for R1, R2, L1, L2, and M. Let's apply KVL on the primary side so we can obtain equation 1. And we apply KVL on the secondary side, we can obtain equation 2. We want to figure out the values for each component. First, the R1 and R2 can be measured using an ohm meter directly. So we already know the value for R1 and R2. For other values L1, L2, and M, we need to carry out 2 open circuit tests to obtain L1, M, and L2. The first open circuit test, we open circuit the secondary side and we connect the primary side with the function generator and apply the KVL on the primary side. We can obtain equation 3, and apply KVL on the secondary side. We can obtain equation 4. In equation 3, R1, we know R1. We measured R1. And also we can measure V1 and I1. V1 and I1 can be measured. Omega is our frequency. So in equation 3, there is only L1 unknown. So we can calculate L1 from equation 3. Equation 4, we can measure V2 OC. OC stands for open circuit. We can measure VOC. And we also measured I1. So M is the unknown variable we can calculate. So using equation, we can calculate the value of M. So by open circuit the secondary side and connect the function generator with the primary side, we obtained the value L1 and M. So L1 is known, M is known, R1 is known, R2 is known. We do not know L2. We will carry out another test to do measurements and calculate L2. So the second open circuit test, we open circuit the primary side and connect the secondary side with the function generator. And we apply KVL on the secondary side. We can obtain equation 5. In this equation, V2, we can measure V2, and we can also measure I2. And R2 is already measured, omega is known. L2 is the only unknown variable, so we can use equation 5 to calculate L2. Now let's take a look at what we need to do in this lab. The first, we need to measure the parameters of the transformer as outlined in the introduction. Step A, we need to measure R1 and R2. Use the ohm meter directly. Second, we need to construct the circuit as shown in figure 4. That is, open circuit the secondary side and connect the function generator with the primary side, and measure V1, I1, and V2 OC, and estimate L1 and M, and also estimate the turns ratio. Step 4 is construct the circuit shown in figure 5. Figure 5, that is, open circuit the primary side and connect the secondary side with the function generator, and do the measurements to determine L2 and K. Here, M equals K times the square root of L1 and L2. We know M and we know L1 and L2. We can calculate K. Be careful that do not measure V1 and V2 with the oscilloscope at the same time, or you will be shorting out the two sides of the transformer. And the solutions of pre-lab questions will be discussed in another video. Yeah, thank you.